Wow, this meeting actually is happening. It's great. It's been 3 years in the making, and it's wonderful to be here. It's super important for the students. It's great to be here and seeing old friends and colleagues. That this is such an important part of us growing up together and developing friendships and partnerships throughout. So it's a really wonderful opportunity. Thanks for inviting us and providing this chance. And I just wanted to take a moment just to step back and pause and think about, yesterday was Father's Day, at least is it Father's Day here too? Is it? And thinking about kids and what are we leaving to the next generation? And part of this talk is because I'm coming from there, because about 3 years ago, we sat back and looked at, what can we be doing best right now in service to the needs of society? And clearly biomolecular sequencing was going to be a game changer in the future. And so sitting at the Smithsonian, at the National Museum of Natural History, which has the biggest collections, what should we be doing ethically, responsibly to meet that challenge, like in service to society that's consistent with our mission to create knowledge and disseminate that out? So that's why I'm here, because I'm going to present kind of at least what we think we can do to accommodate these eDNA workflows and also kind of support a national and international strategy towards this endeavor. And this stands on three general principles. We've launched this program. They wanted something in the ocean, so it's an ocean DNA program, but you could think about it for any system as well. But it stands on three pillars. And again, you guys are all talking about sampling design, technology, proficiencies, and that's all going to be moving forward, right, no matter what. But what can we do as a museum that's kind of future-proofed to make sure that knowledge that we build will enable all the science that is going to happen? Again, I'm not an inventor, I'm not an engineer. There's a lot smarter people than me that are making automated drone systems and eDNA samplers and miniaturized real-time sequencing. That's all going to come. But what should we be doing right now to make sure that we're best prepared to take on that challenge? And these are the three things that we came up with. One was, clearly every paper that's published is indicating that we lack sufficient reference libraries. Like, again, we are the library of life at the Natural History Museum. We need to do better and go beyond the barcode. And so that's why we proposed one of the U.S. ocean shots in 2021, this U.S. ocean biocode, a little U.S. focus, but you can think about it globally too. And this is where we're going to do kind of ultra barcodes, genome skimming, where we get complete mitochondria and also all the nuclear ribosomal, so all the classic high copy markers that are likely to hang around in environmental sample. It's the same thing. If you skim it, you're going to get those too. So it's a nice marriage of technology and taphonomy of eDNA. So, we are diving right into the collections and sequencing everything we can with ultra barcodes. And we're working with lots of federal agencies in this space to source materials, and you'll see other things. And part of that is also to develop demonstration sites. So I think, Dirk, you're probably going to mention something like this, about where we go to place-based areas and we try to disappear those dark taxa with iterative investigations and going back. And that will also calibrate that, and I'll talk about this in a second in greater details. And then the third really critical thing is we're going to start curating environmental samples. And I don't want to, that's a huge phase shift in the museum community. Like, to go beyond vouchers and phenotypes to ecotypes. And that took many years to convince our administration to accommodate this new material sample type. But it's absolutely critical. These are time capsules. We can't go back and sample the past. So we need to have a strategic curation strategy moving forward, nationally, internationally, towards archiving and biobanking these materials. And I'm going to talk about the implications of that from the museum's perspectives from kind of three big bins: the informatics challenges, the infrastructure challenges, and the regulatory challenges that we were sourcing. So before going any further, I just want to kind of help define at least what we're thinking about as far as environmental samples, because that pertains to regulations and informatics and everything. Basically, an environmental sample is anything that you need to analyze to determine what is in it. Okay, so it's not just filtered water or aerosols or shed DNA, the allochthonous DNA, things that are derived not from the organisms. But you could have ground up malaise traps, you could have fish guts, you could have the autonomous reef monitoring structure, ARMS programs, anything that basically you create a sample that then you have to do some analytical process to create a record of the community composition underneath it. And this creates obviously a one-to-many dynamic. So you've cut the cord in taxonomies, you're not, it's not a voucher that has a taxonomy. So of course that creates all kinds of problems, but what's really nice about it is it pushes it back and it makes it very event-centric. And so it really requires you to track the metadata associated with the sampling event and the protocols associated with that. And that's great because it'll allow us to start establishing rule sets in order for people to provide that information if they want us to curate that material moving forward. So working with the communities to figure out what those rule sets are is going to be absolutely critical, and also then to be able to push it to data aggregators like GBIF and OBIS. So for starters on the Ocean Biocode, where do we stand? Well, one of the first limitations was we didn't have species lists for the U.S. We were like, well, what's this list of species founded in U.S. waters? And so we took some time to generate those lists, authoritative lists. And in fishes, we have nearly 4,000 species of fish, working with partners in the National Systematics Lab, NOAA embedded partners. We've been working with others to generate that list for marine invertebrate species. There's about 23,000 species of marine invertebrates once you've scraped iDigBio and species lists and GBIFs and local checklists, and you do the synonymies and you run them through worms and get your APIDs. That's about where we stand. So at least it gives us a benchmark from which to check how well are we doing towards completeness. And again, on the marine invertebrates, we're really fortunate that we've had a long-term partnership with the Bureau of Ocean Energy Management Group to curate their materials, and so they've funded kind of the genomification of their workflows because they can see coming down the pipelines the use of sequence-based approaches to assess and monitor ecosystem health and change. For the fishes, as far as whole mitochondria, only about 12% when we calculated this a couple years ago. I think this was assessed more than a year ago. 12% had full mitochondria. Again, we want to give the whole menu of options for the taxa that we can based on our collections. This is just the way we should be doing sequencing of collections now. We did a very quick assessment. We had about a third of those sitting in our biorepositories, so we just did them. We did them in the last 9 months. We've sequenced over 1,100 species, and we're in the process of QA/QCing all that and getting it to INSDC and GenBank. That's actually a little wrinkle. It's kind of tough to get past all the QA/QCs on that right now, not just for, surprisingly for fish even, but we are actively cranking through that, and then we have more money to actually then go beyond just the tissues in our biobanks, but go dig into legacy collections and historical collections. We have at least the next third of species in our collections, and then we'll work with partners and everybody, get the lists out there, and go get those next ones. Obviously, I'm here to recruit as many partners as possible. We will need help across the spectrum to source samples. It's the limiting factor currently. From the marine invertebrates, again, the list is about 23,000 species of marine invertebrates that we have names on. Surprisingly, in USNM collections or in our museum's collections, we have 2/3 of those in our collections. I don't know what I would have expected to have in just our collections, but 2/3 is pretty good. I think in thirds, a third is really common you'll get, the next third takes effort, and the last third is this long tail of diversity. And it might just be represented by a singleton. In fact, 2/3 of all the records, occurrence records in the US of marine invertebrates are from less than 10 observations. So rarity's real, and we're just fortunate that we're a national repository and we get a lot of rare things deposited in the collections. And to try to go find all these species and lists is pretty much a major challenge. But again, we're knocking this off strategically. We're going after commercial species, invasive species, protected species, using FAO lists, the Nemesis list for marine invasives, and IUCN Red List. We're prioritizing those. And then we're just like starting to crank through whatever we got. Whatever bin or OTU we've got, we're just genome skimming it. We've done over 1,000 species in the last 3 months, and we're just plowing through it at about 400 every 2 weeks, you know, kind of just going back into the collections. And we're going to run out eventually. But that's where the demonstration sites come in. And also, clearly, not all marine invertebrate species have been described, or not all fish species have been described. So this is where the demonstration sites come into play. And we're taking a strategic and somewhat opportunistic approach to that, going to places that have invested infrastructure, marine labs mostly, places that will have ongoing monitoring, and we're doing bioblitzes there, and actually we've already done many bioblitzes in all the spots. We're also looking at the ecoregions, so we know the distribution of taxa generally conforms with biogeographic regions, so we expect to pick up novelty and an endemism and cover all that. So we've done bioblitzes in all these places so far, with the exception of the Gulf of Maine, but I was just up there talking with the Maine eDNA folks, and I think we're going to tackle that one very shortly. And by that first stab, we've got, you know, again, probably a third of all the diverse, more common elements. But the key is we're pairing those bioblitzes with ongoing standardized environmental sampling approaches. So, you know, filtered water, fish guts, arms, settlement plates, sediment, you know, things that can be standard, the leaf, whatever the leaf litter, kind of these standardized metrics that will be used. We want to calibrate those instruments. Like, we don't need to be chasing every rare little species, but we want to concentrate on our sampling thermometers right now, our biodiversity sampling stations, so that we can register and apply natural history knowledge to all those sequence variants. I'm just going to give a little example from an activity that we did in 2019 at the Oregon Institute of Marine Biology. There was a 2-week BioBlitz that was sponsored by the Western Association of Marine Labs. They were very interested in genomifying and indexing all their species. So they funded the workshop, or the BioBlitz. Smithsonian and BOEM used the funding to support all the sequencing, and then University of Florida and ourselves took the cost of curation of all that. So over the course of 2 weeks, we got, you know, you can see the numbers here, about 800 estimated morphospecies. And again, this was just marine invertebrates, so keep that in mind. And it's all recorded in database and Geom, and I think it's on Bold now. All this stuff is out there. But at the same time, they had deployed these arms, which are basically kind of glorified prefab housing that we put down on the ocean floor and scrape everything off and put it in blenders and look at what occurred. And we used 3 different habitats to sample that. So we wanted to look, one of the ways that we're thinking about metricing how well we're doing is a before and after. You know, how much could you do before you did the BioBlitz, and how much could you do after, right? I mean, it's basically, so every dot here represents the equivalent of kind of a bin. We're looking at just eukaryotes here. We're not doing any of the bacteria, threw them out. And basically the size of the dot is a normalized read number across the different profiles that were generated. And what you see is the x-axis was the ID prior based on GenBank hits, and then the y-axis was the hits based on just the sequences generated in the BioBlitz. So you can see there's generally these general things. The upper right-hand corner is the known knowns. They're already in GenBank. We got them too. Great. The stuff on the right-hand side are the old knowns, which is stuff that was in GenBank, but we didn't get in the BioBlitz. And not surprisingly, that's mostly like algae, fish, stuff that was not under our mandate in the BioBlitz is there. But importantly is the new knowns. What was the knowledge gained? And we improved the ability to annotate those libraries by 20.6%. So we can metric, what's the cost-benefit analysis of actually doing the BioBlitz. So we've moved 20% of the reads into now we know what they were. And that's the big get. I'm using a 15% threshold or 85% identity here because I don't feel confident annotating anything below that for saturation issues. This is all CO1. So the kind of knowns layer. But what's kind of interesting is you can go back in and look at this and you see those 3 big blue dots in there and you're like, crap, we missed those guys. So the whole point of the demonstration sites is to have a second pass where we use eDNA and filter whatever, and then we deploy what we're calling dark detectives to go find those things. We're not looking for needles in haystacks anymore. These are 2 bryozoans and an amphipod that we missed. Like somehow we missed them in morphosorting or whatever. Go get them. Go collect them. We know where they're likely to be. And so we do this iterative approach where we do 1 layer, 1 BioBlitz, and then we look at our profiles after that, and then we figure out what taxonomists, what hunters and collectors do we need to bring for the next tier of the BioBlitz to improve, even more incrementally improve those libraries. We're going to be doing that this year in the Indian River Lagoon and the Chesapeake Bay, and growing that as we move forward at those different demonstration sites. And lastly, the other pillar was the environmental samples. So relative to, like, these are, it's just absolutely critical. You know, we got to do this. This is nuts, like, that we don't have a national strategy to curate environmental samples. You know, they're just representative. We can't go back in time. We can sample now. We may not have the perfect way to go, but if we don't do it now and get behind that, we're going to really regret that we don't have that strategy. And so that's super important to develop and accommodate that in natural history collections or in certain repositories. So to figure out that in scope, we did a survey over the pandemic. This week we created an environmental collections working group that had representation across all the different departments in the museum, botany to entomology to even paleo, actually. And we distributed the survey to about 100 respondents. It included agencies, tribes, academics, state, local folks. And basically, we wanted to get, you know, we know it's exploding, but give us some, we needed to kind of frame what it was going to be. And what are you using it for? So again, it was pretty remarkable. People are going to be expecting to collect tens of thousands of things over the course of the next 10 years. I mean, it shouldn't be unsurprising, right? This was a couple years ago, and now here we are. And they're collecting for all sorts of stuff, which we've all heard: sediment, filtered water, guts, aerosol, mucus, you name it. There's all kinds of different sample types. The type of use from a survey respondents were kind of split. You know, some were targeted assays and some were meta-barcoding. You know, it kind of makes sense where, you know, what they were using it for. And importantly, they're on the restrictions. Like, if we're going to store material samples, are there restrictions for future use? That was a really important question to ask, because we were like, huh, that's interesting. I don't know what I expected. But yes, you know, about a third of the respondents were like, yes, there are restrictions. Museums are a little hesitant to inherit restrictions of use. Another third was like, yeah, go ahead and use them for whatever, no problem. Another third was like, that's a really good question. I don't really know how to answer that. So that was good. But so we've tried to get ahead of that and thinking about implementing a way of according with and enable fair and care use principles for these samples. And so we've been looking at the local context, biocultural label, the local context hub, which can tag various conditions, labels and conditions on material samples and arcs moving forward through the value chain. And so we're looking to explore that. The main eDNA EPSCoR group are early adopters of that. They're using the Geome system to tag their material samples. And I think this is absolutely critical with the news that we're seeing about, you know, human DNA in samples now. We should get ahead of this now before it's too late. I mean, this should just be part of putting it up front in negotiating terms of usage and conditions. And we need to develop the information systems that can track that knowledge through the metadata cascade. So again, as we scope this and thinking about the major challenges ahead, we came up with these three main bins: informatics, infrastructure, and regulatory from the museum's perspective. And on the informatics, clearly this is a new sample type. Is going to require a new data management system. This one-to-many, it's not inheriting the taxonomy. You know, we can deal with the curation of the object, but having a system that can track that is super important. Importantly, versioning is improved reference libraries. Like, what is it? And I'm super excited. Well, I'll throw a bone out there to the GBIF folks in a moment. But I'm really excited because I was really worried that we were going to have to develop a system that would version that moving forward with improved libraries. And our data is still a little siloed in departments. You know, there's the vertebrate group and the invertebrate group and the entomology group, and they don't necessarily share the same taxonomy, backbone-y kind of things, or the collectors. So even in the museum, we're still very siloed. So we need to figure out that from the informatics system. Oh, again, so here's the toss to Thomas and Tobias. You know, thank you so much for handling this, because if you haven't watch this webinar that was last Thursday, I think. Go check it out, super important. But I think this is going to be a game changer in how we track occurrence records from material samples. It will give us, all the different agencies and data providers, something to shoot for. And so we don't have to think about aggregating in little bunches and moving it up. Everybody can just be pointing to the same system, no matter whether you're a small lab or a federal agency. You know, it's totally fine. But again, we have something to shoot for aggregating and spooling that up, because if you use the right identifiers, you can always pull it back down and build wrappers around it with your own flavors as you need it. So again, it's totally fine. I think it gives us a great target for that. But we still, at the museum, are going to need to develop and modernize our information system to track this. And so it's this one-to-many. There's a new metadata. There's new material sample properties. So looking at the Darwin Core extensions, looking at the GSC and the mixed standards, and thinking about what's missing in that and needs to augment. So we're doing the horizon scans of all the data systems, including Canada's, Finland, Australia, New Zealand, Netherlands, you name it. We're looking at all that to figure out which pieces of the Legos we need to keep track of. On the infrastructure, clearly this is a big issue. We are siloed. Who has custodialship of a mixed sample? Is it in the VZ? Is it in IZ? Is it in botany? Because they have all of them in it, you know? So do we need to stand up a whole new department of mixed samples? And we've kind of, that was a big problem, because we have rules, SD 600, about curatorial oversight. Who's responsible for the collection? Who makes the decision as to whether this loan goes out? Because it will be somewhat destructive sampling of a limited resource. So we have to make those decisions. We also have the, well, we talked about the cross-departmental, and then critically staffing. If we opened our gates to environmental samples, we'd be swamped instantly with samples. So how do we grow into it? What's the additional staffing? And, you know, bricks and mortar, you know, real issues there. We queried the museum community and decided that we wanted to adopt this chimeric model. Whoever, curators or whoever's in charge of bringing that in, would maintain custodialship and permissions of that particular sample type. So it's a fish gut, it might be under fishes. If it's plankton, it might be under invertebrate zoology. If it's algal washes or whatever, it might be under botany. But then, so that allows us to use our existing systems of curatorial record without creating another department and all the heaviness associated with the bureaucracy there. So that's where we are in the chimeric model. But clearly, we need to kind of pace ourselves in the growth of taking on samples. So we're looking after NMNH and partners right now, and looking at other agencies, et cetera. But it's absolutely going to require additional funding and allocations. There's no way we can operate with our existing budgets to accommodate the growth, the projected growth of environmental samples. From a regulatory standpoint, this got a lot of people in the museum super nervous, right? They were like, wow, okay, there's reporting obligations when you bring stuff in, at least in the US, like you have 180 days to report what was in your sample or identify it. Well, if you don't analyze it for 180 days, how do you report that? What if somebody takes a loan and they find whales, or they find a threatened species or an invasive species? Are we obligated to report that out of our own material samples? What are those rules and regulations pertaining to that? These are all issues. Moreover, like, do we need permits? Are these regulated materials? Like this, you know, what is regulated, what falls under take, detection, all that stuff created a lot of stress in our legal perspectives. And again, we're in the forever business. You know, somebody borrows this 50 years from now, you know, what sort of triggers? Who do you go back to ask permissions, et cetera? On that one, we did talk to our general counsel, and they determined that right now eDNA don't require an incidental take permit, and they fall within what they're considering the category of wildlife byproducts. So it gives us a little cover for the moment. Moreover, but we're still not sure about the regulatory requirements. We're still having negotiations about that and what that means. So stay tuned on that. But at least we feel a little more confident in taking on, that was part of the big hurdle of getting administration to agree to think about taking these sample types. And of course that leads us into a national strategy and framework and talking across the interagency space in the US about this. So there is a subcommittee out of the Office of Science and Technology from the Office of the President that has been tasked to craft a national strategy. Adam, and is anybody else? I think we're the only ones here on that.
Rick.
Oh, is Rick here? Yeah. So we have a task to create a strategy document. Again, it's pretty high level. The target is agency heads, congressional representatives. Again, we recognize we want to harness the power of this technology to transition to kind of this blue economy. Framing it in the opportunity to create markets, right, is important. But we also realize, we need to improve everything that was mentioned, improve the coordination, communication, and harmonization of methods across the different agencies. They're very siloed, that was mentioned earlier. I think, Adam, you mentioned that. And we want to make sure that we develop congruent implementation plans that, where we learn from each other and coordinate that eDNA application. So this is happening now across all this interagency space. I'm co-leading with Kelly Goodwin, Noah, and Mike Weiss out of ONR. And a lot of that stemmed from another meeting that was canceled and pushed back for years and years. The second meeting that was held at SWIRP. And that was, that's where a group of us said, well, we need to have a paper that comes out that lays the on-ramp towards a national strategy. So that this paper just came out that Ryan was the lead author on, but had a lot of contributions from lots of authors, so take a look at that. But that basically challenged us. Now we do need a federal strategy moving forward. And that will be launched at the third national workshop, which is going to be hosted by Johns Hopkins Applied Physics Lab. It's geared to be timed with the Capitol Hill Ocean Week in the US, which is June of 2024. We're going to be co-hosting that as well, based in Washington to have the maximal impact to launch this national strategy. And then we have to do an implementation plan and all those things that we've talked. And again, please come talk to me up throughout the week here. I'm really excited to tap into that. But of course, we're not just thinking nationally. Clearly this is set within a larger planetary ecosystem. There's lots of ongoing activities throughout the pandemic and lots of virtual meetings and lots of things got launched during the Ocean Decade. I just highlight, the OBON group, which is the Ocean Biomolecular Observing Network based out of Plymouth. That was one of the endorsed UN Ocean Decade programs. They have a number of great sub-programs nested within them. And I'm just drawing attention to the BBOP group, the Better Biomolecular Ocean Practices group there. But again, there's national, the Australians nested in there. There's 27 endorsed sub-programs in that at this point. And also a new thematic bond has been launched called OMIC Bond, which is a UN-endorsed program. It's the first thematic bond that cuts across all the biological observing networks to try to harmonize sequencing methods to maximally benefit from the approaches. So those are all being done. We're also, of course, in the national strategy looking at across all the other national and international agencies that are launching similar programs. Just one example from the BBOP, creating a new data standard system. Highly encourage you as you develop your protocols to deposit them in the Ocean Best Practices repository, because then we can make them machine readable, we can start making them discoverable, we can mix and match different subsets of the workflow. We've tried to map out all the different steps and chains in the process to come up with this minimum information for an omics protocol. Again, all heavily machine readable, and you can choose and also have abilities to choose by how much money do you have, how many people do you have, where are you located, what's been used in your area for your target group, all that kind of stuff to give people options moving forward. Again, setting the stage to allow the growth of this new technology and economy. On our horizon immediately, towards the curated reference library, I think that would benefit everybody. Everybody's talked about that, the trusted curated reference library. We first have to get agreement that everybody will agree that we'll use this library. It's amazing, the FDA thinks they need to stand up their own, and NOAA will think they need to stand up their own, and USGS will, or whomever. We need to just have a stakeholder meeting, put everybody in the room and say, okay, can we all at least just agree that if we follow these rules and governance and checks and balances, we use good phenotypes and they're well vetted, you guys will all get behind this. Because GenBank doesn't want to police this. BOLD, it's great, but it's not necessarily policing this in that way. So the first step, and very shortly over the course of the next probably 6 months, is to get a meeting of all the different stakeholders and practitioners to agree that we'll build a national reference library, okay, and how we do that. And finally, I'm just going to circle back and end on this. And again, it's an incredible opportunity right now. The Smithsonian's trying to position itself in that space and also in the national space. I'm really excited to be here for the week and talk to folks, and I want to hear more about what everybody's doing and recruit partners in this endeavor. You know, the best thing I've ever heard, we were talking with Cisco Warner at NOAA, and you know, he was part of the first working groups that happened at the Rockefeller meeting, at least in the U.S. And you know, it was a little touch and go on that. But it was amazing to hear him say, he was like, wow, you know, we thought this was science fiction. And this is just like, what, when was that, 5 years ago? And now he's like, we needed this yesterday. Like, so we've gone from science fiction to urgency in half a decade. And so it's really beholden on us. I mean, this is the group that's going to make the difference in the world as we move forward. So with that, thanks. Leave it up to you.